Hello friends, welcome to another video. In today's video, we are going to look into a moving average in a matrix visual. It's actually a very interesting problem, was posted on Power BI community forum 2 or 3 years ago, and I had a chance to work on this one. Let me explain what the actual problem is and what the solution is going to be. So let's look at the problem. So here the user posted like it's called data smoothing or moving average in metrics. So what the user has is a length and weight. And so rows has a length and the column has a weight and there's a values of quantity. So what the user want is to smooth out the difference between the cells in the heat map. So basically average of surrounding cells calculation. So what does that mean is surrounding calculation. So I'm actually going to have a sample in Excel sheet here. So I'm just going to bring that to showcase. So here is, for example, the data we have here is in Power BI. So length is um, on the columns. So a bin of 5, and then we have a weight here, let's say 1200, 1400, 1600, 1800. So what user is looking for when he says a smoothing average, whatever data point we are in the cell. So right now, let's say I picked up this one, 2. So go up 2 rows and go down 2 rows and go left 2 columns and go right 2 columns. So this is like when I'm at the D4, this is my this is what the area I want to work on. So once I go 2 rows up, 2 rows down, and 2 columns left, 2 columns right, which becomes this whole grid, and then I take the sum of this, which is 243. I have put it here 243. The sum of this is 243, and then divide it by 10. Why we were dividing it by 10? Because our bin size for the length is a 5, a size of bin is 5, and multiply by 2 because we're moving in the direction of 2 in both sides. So that's, we divide by 10, and that then round it off, and that will give us the average or the a moving average in the matrix. And that's what we want to first we want to calculate this and then use the conditional formatting to highlight the data point. So let me show you this in an Power BI. How does it look like as of now? So here a simple table, flat data, and so if we look at the data, it is just the length and the weight. I think weight is on the columns, and then the quantity. And first part what we did is we created a bin for length and weight because we want to bin these together. And if you never use the binning, you can actually do the grouping or the binning in Power BI on a column. So here I have a weight bin. So if I open this edit groups, so what I have is a weight bin. I call it weight bin, and then the group type is bin. You have a multiple options here, then size of the bin, and it automatically detects the minimum and the maximum value. So the bin size is 5. So this is how I want it to be, the size of the bin. So it automatically grouped those together. And similarly, we did the bin for the length. And let's look into that, what the length bin is. So that is a size of bins again, and it took the minimum and maximum values, and the bin size is 150. So this is what the requirement is. So once we created the bins, and if I visualize the data, so I have a weight on the columns, weight bins on the columns, and a length bins on the row. So this is what it looks like, and the sum quantity on the values. And what I did here is a simple conditional formatting. So if I look into the conditional formatting, background color, what I did here is the lowest value is green. Again, this is the requirement, and the center value is custom, which is 7. Again, this is came from the user. That's what he wanted it to be, and that's a yellow, and the highest value is red. So now this is what the output look like, and what you want to be smoothen out the average. So like for example, pick any cell here. Let's see if we are at this cell, which is on we have 1350 on the rows, which is the weight or length, and 65 is the weight. So if I'm 172 here, I need to go 2 rows up and 2 rows down, and then 2 rows left and 2 rows right, and whatever that metrics turn out to be or grid work out to be, sum those numbers and then divide it by 10 to calculate the moving average. The one which I showed you in an Excel sheet is basically what I took is like a 1200. So this is the data we looked into the Excel sheet. So this is the grid when I'm at the two. So 2 rows up, 2 rows down, and 2 rows left and the right. And then once I figure out what that matrix is, and then I sum this up. So this is what we're going to do with the DAX. It's really interesting problem to solve. So let's look at the DAX, how I solved it, and what the end result look like. All right, so let's start writing a measure. So first what we need to do is, let's say what the weight bin size is. I will store that in a variable. So bin size is 5. We know the weight size. Weight is on the columns, and that's the bin size we use for the weight. And what I'm going to do is multiply this a by 2. The reason why I'm storing it in a variable, let's say if we have this metadata coming from a table, then we can just replace this 5 with I always like to store the values in the variable so that it can be easily changed. So weight bin size multiplied by 2. The reason why I said like we're dividing it by 10, because the bin size is 5, and multiply by 2 because we're going 2 rows right and 2 rows 2 columns right and 2 columns left, and that's why what the bin size we multiplying by 2. If the bin size was 10, I would just simply come here and change the bin size to 10, and then rest of the calculation will work. But let's say right now the bin size is 5. Now next what we need to do is we need to find out what is the bin on the rows and column we have. So what we can say is maybe current weight bin. So that is pretty simple. We can have a selected value, and then that will be our weight bin. Similarly, what we can store is current length bin. The reason why we are storing this, because we want to find out where we are in the matrix right now. So basically it's like in Excel you're saying D14, so we are calculating where we are, whether we are the D or E in the cell, so and the row where we are in our matrix visual. So we have a then length bin. So now this will give us where we are in our when we're looking at the cell. So we know if I'm at this cell, so or maybe let's just I just want to make sure that you understood what I'm doing here. So basically if I'm at this 90, what I have is my weight bin will be 45. That's what I am. And my length bin will be 1200. So that's what that particular selected value is giving. So where we are in that particular uh, cell. So now once we have this, now what I can actually, we have the weight bin size, we should also store the length bin size here as well. Again, this data could be stored outside somewhere coming from a table, but in this particular case, we know we have created the bin, the weight bin, the bin size is 5, and the length bin size is 150, and that's what I'm storing here. So now once I have this information, I know now what the bin size is for the weight and length, and also I know where I am in the cell, what weight I am at, what the weight bin is, and what the length bin is. So what we can do, spelling is wrong, length bin. Okay, so now we know, now we need to move left, and first we need to go either left, right, or either way. So let's do that. So what we're going to do is we should also have a total length bin, which should be length bin size multiplied by 2. So because rows and columns, we're moving, and so, and now let's store two more values in a variable. So move rows, so how many rows we want to move, two, and how many columns we want to move is 2. So now we know how many rows and columns we want to move, and we know where we are, and we know the size of the bin. So now what we can do is pretty straightforward from here. So what we can do is minimum, let's say, length bin. So minimum length bin is going to be my current length bin, so minus my total length bin. Because let's say if I'm at the let me make sure let me actually write it down here, and minimum length bin and the maximum length bin will be current length bin plus total length bin. So let me make sure, let's return some value here so that my it doesn't give the error. So just to explain what we're doing here is, so our total length bin is 300 in this case, because 150 multiplied by 2, 300, right? So this is 300. So my current length bin is, let's look in the visual here, in the matrix visual. So let's say if I'm at the 3000, so what I'm doing is I want to go 2 rows upward. So 3000 minus 300 will take me to the 2700. So that is the 2 rows up, and 3000 plus 300 will take me 2 rows forward. That will be 3300. So now I got the range, the rows range where I'm at. Let's say if I'm at the 2700, minus 300 will take me to 2400, and 2700 plus 300 will take me to 3000. So that gave me the range of the rows that I'm interested in. And the similar thing what we're going to do is for our I'm going to copy this. Now this is for the rows, and okay, sorry, and let's, and now minimum weight bin will be current weight bin. Again, we're just going to do the same thing, minus total weight bin, and maximum weight bin is going to be current weight bin minus plus total weight bin. So that's to make sure what we're doing here is, again, the weight bin size is 5, and multiply 5 multiplied by 2 is the total weight bin, which is 10. And again, this is, now it is on the columns. So basically if I'm at the 100, so 100 minus 10 will be 90. So we moved 2 columns backward, and 100 plus 10 will be 110. We move the 2 column forward. And similarly, if I'm at the 150, 2 columns backward will be 140, and because 150 minus 10 will make it 140, and 150 plus 10 will make it 160. So that's what we're doing here. The one thing that these move rows and columns should be, I haven't used it, it should be here, and instead of move columns will be total weight bin, because bin is on the weight bin is on the columns, and the move rows will be on the length. So now this is more dynamic. We are basically saving these settings here, how many columns we want to move, what is the how many columns we want to move, how many rows we want to move, what is the size of the bin of the weight, and what's the size of the length bin, and that's we're storing, and then we're calculating everything. So now what we have is we have basically the area what we are interested in terms of the rows and the columns. So now this has become super easy from here. What we just need to do is calculate. What we want is sum of our quantity column, and then we are going to flat data. So what we want is weight bins is greater than, because now we have the range is minimum weight bin, and let me actually make it smaller and copy this thing. And so this will give me the range of, so what I want is filter my flat data table where my weight bin is within the minimum weight bin and the maximum weight bin, and also my length bins is greater than equal to maximum sorry, minimum length bin, because it's greater than equal to, and flat data, copy this thing again, is less than equal to maximum length bin. So this will give me what my sum is going to be, maximum length bin. So let's actually get the, they call it total quantity. Now once we have this, let's return the total quantity and look at the output. The one example we have in Excel sheet, because that's based on the real data, and see if we get the 243 in cell of this cell 1210. So what I'm going to do is make a copy of this page. So let's stay as it is, duplicate page, and moving average, let's bring that column in our metrics and remove quantity here for now. And so here at 243, if you look at the 1210, which was 2 before, the value was 2, now it is 243. And why we are getting 243, again going back to Excel, this is the raw data, and when we are the 2, which is this is actually 1200, if I make it more close to what the reality here is, and this was is 10 basically, so 0 5. So now that is what giving us 243. So now for each column that the same calculation is getting calculated. And now once we have the total quantity of the area, what we need to do is we just need to as I said, divided it by 10 and by the total weight bin. So what I just need to do here is divide total weight with total weight bin. So now that is what the average is going to be, and once we have that average calculated, and from here we will see the final output. So now you can see the average will be 24 for that specific cell, because 243 divided by 10 is 24, because it's a whole number. And now we have this. So I already had done conditional formatting on this one, so I'm going to show you guys how does the final output look like. So look at the data smoothing right now. So you can see this is where the heat is, and it's a heat map, and then yellow, and then the rest is blue. So final output actually is this is what it looks like, because we don't want to see the values, it's just the color we want to see. So this is what the final output looks like. So this is the final output what user asked for, and that was the original output was this without data smoothing. This is how it did look like, conditional formatting. But after we created this moving average, this is the output looks like. Again, this was really interesting problem to solve. So there is a couple of things in here, is like how you can understand the problem. I did it in an Excel sheet to understand how we're going to do and then stored everything in the variables, so that's easily we can change it. And then we did the calculations, and then everything turned out to be worked out finally the way the user was looking for. Anyhow, again, this was just a fun video. This is coming on Saturday. You guys, hope you guys have a great weekend. Until next video, have a good day. Do subscribe my channel. Thanks for watching. Thank you. Enjoy your weekend. Bye for now.